Hey there, and welcome. Today, we are going to be cracking the code on a classic GCSE exam question all about straight line graphs. We're going to break it down piece by piece so you can look at a question just like this one and know exactly what to do. So let's get right into it. All right, here it is, question 6, taken straight from a GCSE paper. Now, you can think of this as a little two-part puzzle. First up, we've got to find the equation for this line they've given us, line L, and then we're going to tackle a second line that's parallel to another one. We're going to do this together, step by step. Okay, so this right here is our master key for pretty much any straight line graph problem, y equals mx plus c. For the first part of our mission, all we need to do is figure out two things. M, which is the gradient, how steep the line is, and c, which is the y-intercept. That's just the spot where the line crosses the vertical y-axis. Right, so first things first, let's hunt down m, the gradient. This is just a number that tells us how steep our line L actually is. The way we figure out the gradient is with a simple formula, rise divided by run. Just think of it like this. How far up or down do you have to go? That's your rise. For every step you take across to the right, that's your run. Rise over run. Simple as that. Let's have a look at our graph. To get started, we need to pick 2 points on the line that are super easy to read, where the line crosses the grid perfectly. Can you spot one? Right here at the top. That's the point 0, 5. Now, how about another one? Look down here. Perfect. The point 2, 1. Okay, time to do a little bit of math. The rise, which is just the change in our y value, goes from 5 all the way down to 1. So we calculate 1 minus 5, which gives us -4. The run, or the change in x, goes from 0 across to 2. Well, that's just 2 minus 0, which is 2. Now we just do rise divided by run. That's -4 divided by 2, which gives us our gradient, m of -2. And that negative sign makes total sense, right? I mean, just look at the line, it's sloping downwards. Awesome, we found m. Now for the second part of our code, finding c, the y-intercept. And believe me, this part is way easier. So the y-intercept is literally just the point where our line L cuts straight through the vertical y-axis. All we have to do is look at the graph and read the number. Can you see where it's crossing? Yep, that's it. It crosses right there at +5. So our value for c is just 5. See? Told you it was simple. So let's put it all together. We have our two values. M is -2 and c is 5. We just need to slot them back into our master key equation, y equals mx plus c. And that gives us the final answer for part A, y equals -2x plus 5. Done. All right, part A is done and dusted. Now, let's move on to part B. This next bit builds on what we've just learned about gradients, but it introduces a new idea, parallel lines. So the question gives us a totally different line called m, and its equation is y equals 5x. Our job is to write down the equation of any straight line that is parallel to this line m. Now listen up, because there is one simple golden rule you absolutely have to remember here. Parallel lines are like train tracks. They run alongside each other forever and never ever meet. And for that to happen, they have to have the exact same steepness. In other words, they always have the same gradient. Always. So let's look at line M. Its equation is y equals 5x. If we compare that to our formula, y equals mx plus c, what's the m value? It's clearly 5. This means that any line that's parallel to it must also have a gradient of 5. The only thing that can be different is where it crosses the y-axis, that c value. This means pretty much any equation that starts with y equals 5x is going to be correct. You could write y equals 5x plus 1, or y equals 5x minus 10, or like we have here, y equals 5x plus 3. Any of those would give you the mark, because they all have that all-important gradient of 5. So let's do a quick rundown of our key takeaways. The equation for any straight line is y equals mx plus c. M is the gradient, and you find it using rise over run. C is the y-intercept, which is just where the line crosses the y-axis. And of course, the golden rule, parallel lines have the exact same gradient. So we've totally cracked this exam question. But this formula is incredibly powerful in the real world. It's used for everything from figuring out your phone bill to predicting trends in science and finance. So I'll leave you with a final thought. Now that you've cracked the code, where else do you think this formula might be at work?